Alright, welcome back. We were reviewing for the final, got through some non-programming stuff, and then we just dove right into programming stuff with Python. So remember that I will be giving you coding questions on the final. They will be Python coding questions. I can't really give you anything with Scratch, sadly. So just prepare to write some code, paste it in the Canvas text box. If you're following along with me, you're understanding everything that I'm writing, you study your programming assignments and all the other in-class example programs that I've made and made available to you, you're going to do just fine. Okay? I'm not going to make you think horribly hard about a certain problem. A test is not the right time for that, is what I'm trying to say. So I'm just going to make sure that you understand how to program with some questions. Okay, that's all. So let's get back to Python. We were talking about for loops, and a fancier example is this one. So let's prove that the following statement is true. So prove the statement to be true with code, and now it's hard to put this all in the same line, darn. How about I say this? Prove this following statement with code, colon, that. So remember how to read this. This backwards E means there exists. So there exists some x. X is a number because of what we're doing with it. X is a number, and it's between 32 and 37. And, remember, this means and x is prime. Okay, that's how you read this. X is prime. That's a predicate. Okay, it's like a logical function, if you will. So that's how we can check against all that stuff. So the idea for proving this is to if I make a new file. Yeah. If I make a new file and I'll say, well, I want to prove this by iterating. Okay, so what we're going to do is try all the numbers between 32 and 37 using a for loop. So we'll use range to get that. Range 32, and it's not 37, but 38. Let me prove that to you. So try all the numbers between 32 and 37. That's the same as doing range 32, 38. Because that will give you all those numbers in between. Okay, that's what we want to do. So for x in range, blah, 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 we'll see if x is prime. We'll make like an is prime function. Is x prime? Then proved, like we could make a variable saying, did we prove it? Initially that's false, we didn't prove anything, but if we found a prime number in between, we have proven it, okay? Did we prove it? Equals true. And then if we end up down here, and that means we've tried all the numbers, tried all the x's between 32 and 37, we might have found a prime one. If we did, we'll print it out. True. Otherwise false. Okay, that's the idea. And there will be a prime number there. So let's find that. So I'll say for loops 2.py. How about that? And so we need to make this is prime function. That is necessary. We might be able to get lucky if we look in the math library. Maybe there's like a prime function, but no, not quite. So we'll have to make it ourselves. So is a number prime? A number is prime if all the numbers between 2 and x don't divide evenly. So there's this modulus operator that I want to remind you of that gives you the remainder of things. So remember this modulus operator, like, all right, for modulus 2, divide by 2, get the remainder, it's 0, it goes in cleanly. 3 mod 2, that's 1, it doesn't go in cleanly, okay? That's how we can do this. We can say for, we'll try all the numbers between 2 and x, see if any of them divide evenly. So for v in range x 2 and like x minus 1, I guess, because x will divide evenly into it. That's the idea. So we'll just say range to x. So if x mod v is equal to 0, it divided evenly, in which case return false. Uh-oh, we found that it's not prime. Else, if we get all the way down here, the number is prime. Return true. So I think that's correct. There might be a bug and we'll come back, but that's what I got for you at the moment. And oh man, we did find a true prime number. It looks like we'll print out x when we found that it was prime. 37 happened to be prime. 33 is not prime because it's a multiple of 11. 35 is not prime because it's a multiple of 5, but 37, that one's a prime number. True. Cool, huh? All right, that is what I have for you there, and let me actually go and rename these files so that I don't get them lost between like which lecture had what. Okay, much better. So if I were to change this between 32 and 37, like if I were to change this, like okay, it's between 32 and 36 now, then suddenly we can't prove this theorem anymore. We can't prove this statement. All right, so that just goes to show that there are ways to make it false. So hopefully it makes sense that we proved this. Like we found the x. You prove it by finding it when it's a there exist. We found the x. The x was 37. Okay, it's between these things. There it goes, and it was prime. All right, so that's very nice. Now let's talk about functions in detail because we talked about them a little bit in that prime function. But let's go crazy. So a function, it's got two parts. So you can define a function using def, and that makes it available to be used, and then you use it somewhere. And a use is called a call in computer science. So you call the function with some arguments, and the function itself takes some parameters in the same places for those arguments. And optionally, the function might return something, and you'll save that. So return something if you need to, and remember to use that return value if it does give it back. All right, so what we're going to do is program the ROT13 or ROT13, however you say it, encryption algorithm, where you take a number, you take a letter, and you give it whatever that letter was 13 characters down the line. Okay, so that's the idea. F gets replaced with S and vice versa. So T gets replaced with G and vice versa. So hello turns into Uryb, and let's just make it happen. We're going to say def ROT13, and I'll take some string S, and then we'll do fancy stuff, and we'll just return encrypted S. That's the idea, okay? And this fancy stuff is where we need to figure out what to do. All right, so let's do that. I will call it, how about ROT13? So it's going to take some string S, and we'll get the input from the user, like, hey, not sure what to do there yet, but eventually we're going to need to get a string from the user to encrypt. So only spaces in capital letters, please. So we get a string back, call it I don't know, to encrypt. String to encrypt, maybe. So we get that from the user. Then we'll say print ROT13. So we're going to encrypt it. String to encrypt. Okay. Functions are really nice because functions are really nice because they allow you to like delay thought. like, okay, I want to do this. Like, I want to encrypt this string. I'll just pretend I have a function that does that. And then I'll finish this code here, and then I'll get back to writing this. All right? So that's, functions are really nice for that reason. Okay, so let's make this happen. So what I would like to do, the way that I'm going to solve this problem, there's many ways, is we're going to eventually have to iterate through the characters of S, building up a new string. Starting out empty. So we're going to build up a string into this one. And that's the encrypted form of S. And we're eventually going to need to go through every character of S. We can do the for loop for that, actually. A string is very much like a list of characters. We can say for C, for every character in S, we can do stuff. We'll have to encrypt it somehow. So what do we do? There, we'll have to figure that out. But that's kind of the idea. And I think the first thing that I want to do is make a table. Okay? I'm going to make a table of all the characters in the alphabet. So I'll make a list of chars. The first one's A, the second one's B. I'm not going to bore you with this. I'm going to be back after I type all this out. Okay, I'm back. I've made a very long list of all the characters in the alphabet, and then I'm going to go and encrypt each character. I'll make another list. Encrypted chars. So in the same spot, the first spot is going to be the encrypted form of A, which is going to be N. Okay? So I'm going to go in order like that. So I'll be back after I do that now. All right, so A goes to N, B goes to O, and then all the way over here, Z goes to M. So hopefully that's making some sense to you. And so now, with that in place, we can do fun stuff. We can go and find what character we need. Okay, so we're going to, might have to break this out into another function, but we'll say, go through every character of S, building up the encrypted string. Well, first of all, if the character is just a space, we want to preserve the spaces and not encrypt a space. We'll just keep it a space. So in the encrypted string, plus that space. Okay, so keep spaces, don't encrypt them. So if the character that we're looking at is just a space, we're going to add it to the end of encrypted string, just as it is. Otherwise, it's a character that we need to encrypt. We'll say encrypt C, maybe, and then we'll add that to encrypted string. I do feel like splitting this up into two functions because this is getting big. And that's what you can do. That's the call that you can make as a programmer. So I'm going to make an encrypt function that encrypts a single character C. Okay? And it's going to use these tables that I've made. Don't need them there anymore. And the idea is we just need to go through chars, find C, and then go to the same index in encrypted chars. Yeah? And once we go there, we'll find the encrypted version. Like if it was a C, then we're going to give back a P and we'll return that. Okay? So we'll do it like this. For I, because we need the, we're going to have to use numbers for indices. For I in range, len, For I in range, len chars. There's 26, but it's fun. Why not? We'll use len chars. So go through every valid index of characters. We'll do if chars at I is equal to the C that we passed along, so this is the thing that we want to encrypt. We found the character. Maybe we were looking for B, and we found it. We're going to save that. We're going to use that fact to return encrypted chars at I. Okay? We can do it like that. And then we should never get here. But if we did, if the user gave us like a lowercase character or something, we can say return like question mark. That will help. Alright, so that's how we can encrypt things. We'll just find that character that we want to encrypt in the encrypted chars list and go there. Hopefully that's making some sense. So we're going to get an input string from the user and we'll encrypt it for them. So my string is hello, all capital letters. Oh shoot, what have I done wrong? This is none. And that makes perfect sense because I never returned anything. I didn't finish this function. Okay? The function needs to give back an answer because I'm trying to use it. You see that? So we'll say, once we're done now, done building up the string, we'll return encrypted string. And now it should work. In theory, that is. So hello. Urib. Awesome. We can do more with spaces. We can say hi mom. Ovzbs. Awesome. Everything is working perfectly and the spaces are just preserved. Okay, so please study this code. It's a very a useful little example. But that is functions in a nutshell. So we can define them and then we can call them, and every time we call them we pass the same arguments in the same positions. So the function took a parameter called param1, we gave it arg1 to use for that param1, okay? When we call a function, it executes the body of that function with the param1 equal to the arg1, and the param2 equal to the arg2, okay? That's how it works. And that's your cheat sheet, we finished it. The next thing that I want to talk about is randomness. So it's a nice library thing. So you'll say import random. For that, there are plenty of other libraries that you can take a look at. You've got your just the things that are built in. You don't have to import. Like we've used type. That's just immediately there for us, which is fun. Turtle we'll get to. Random is fun. And we've used a lot of we've used a lot of rand int, and also maybe you used uniform somewhere. Also uniform is useful. So the first thing that we're going to do with randomness is make like a random etch-a-sketch, if you remember that. That's that little toy that you can draw things with. It's got those two little knobs that move it left and right, and it draws the picture with lines. So we're going to make the turtle do that randomly. So we're going to have the turtle draw a bunch of random lines in random directions. And maybe we'll stop drawing when the turtle runs outside of the visible screen or something. But that'll be a fun little example of randomness, I think. So I'll make a new file, and then we'll say import turtle, import random. And I won't waste time making the turtle look pretty, but let's get to the meat. So we're going to keep drawing while the turtle's within a 600 by 600 rectangle, okay? So we're going to get the turtle's position and make sure he's still in there. So keep drawing while the turtle is between negative 300, 300, and 300, 300. Okay? That's the idea. We want the turtle to stay in between those two coordinates. 300, 300, negative 300, negative 300. Okay? So the turtle can draw as much as he wants in there, but once he tries to leave, we're done. Okay. So we're now going to randomly do stuff. So while the, I guess we'll have to say, how do I want to do this? While turtle dot, let's get his x coordinate. We can, I think we have to just say pause, maybe. No, we can say x core and y core. Let's do that. So while turtle.xcore is less, no, well, it's between these things, negative 300 and 300, and same for the y-core. The second that's false, we're done. All right. Let's do this. So let's randomly set the direction of the turtle and pick a distance to travel. So our random direction can be I don't know, random.randint 0 and 3 times 90. Okay, so we'll either go 0 degrees, 90 degrees, because that's time if it was a 1, 180 degrees, because the random int can be between 0 and 3. If it was 0, it'll be 0. Don't change your direction. Otherwise, turn by 90. Otherwise, turn by 180. Otherwise, turn by 270. Hopefully that makes sense. And then we'll pick a distance to travel. So distance equals, I don't know, random.randint between like 5 and 100. How about that? That'll be our distance to travel. And so now we'll do those things. So actually move the turtle. So to change the way that the turtle's facing, given a degree, you can say turtle.heading, I think, if I remember it correctly. Maybe it's set heading. Yeah, it's set heading. So we want him to either go east, north, west, or south. And then we'll say turtle.forward distance. Move forward by this random amount. Okay, and eventually the turtle will exceed those bounds. Maybe it won't be random enough, but eventually the turtle will get out of bounds, and then it'll stop. So this etch-a-sketch.py. And here's our turtle, just moving around, doing random stuff. And he's always trying to get out. He's trying to get out, but he's not. He's going up, going down. And so it might take him a while, but eventually he will go out of bounds, and this program will stop. But until then, he gets to make a beautiful picture for us. Oh, there he goes. Okay, so that's fun, and we stop the program. So enjoy that. That's really cool. With just a while loop, we can do that. The second example that I want to give you is a bit more involved. That's when you approximate pi by what's known as throwing darts. So here is the idea in a nutshell. We're going to set a rectangle and pick random points in that rectangle and throw darts randomly within the rectangle. Okay? Alright, so it's kind of weird, but pi can be approximated because here's you pick a square actually, sorry. Square. Pi can be approximated by the ratio of the number of darts that you threw within a circle and outside of the circle, okay? And the ratio of darts, number of darts inside the circle over the number of darts total that you threw is pi over 4, in fact. So we can approximate pi by just multiply that by 4. And this has to do with like the ratio of the areas. So you divide the area of this circle divided by the area of this enclosing square, it becomes pi over 4, which is fun to think about. But we're just going to randomly throw darts. Why not? So let's pick our dart board to be like we can have a 300 by 300 rectangle. Why not? And we'll throw like 1,000 darts. So we'll throw 1,000 darts. For I in range 1,000. And here's what we'll do. We'll pick a random x and y coordinate between negative 300 and 300. And we'll start throwing our darts. let's talk about how to create those random numbers. You can say uniform between -300 and 300. I'm just making it large so that we can all see it. So pick a random spot within the 600 by 600 square to throw a dart, and then we'll say, I don't know, well, let's get the x and y coordinate. X equals random.uniform, -300, 300, and then we'll do the same for y. Darts and pi. And then we'll throw the dart. We'll say turtle dot up, turtle dot go to x, y, turtle dot, and we can actually draw a circle with a turtle. Turtle dot circle, and we'll give it a radius of, I don't know, 5 or so. How about that? And then we'll say, yeah, I think that'll work. I don't know if the turtle needs to be down at that point. Let's just put him down for good measure. And so that's what we can do. And this will work. This will just drop 1,000 darts. Just like that, which is fun. That's very slow, so let's make the turtle go very fast. It'll still be very slow, but here's 1,000 darts being thrown, and we want to keep track of which ones are inside of the circle and which ones are outside of the circle. Let's figure that out. So, we need to figure out if those darts were inside of the circle or outside. And we need to figure out how to do that. And the way that we can tell is checking the distance. Between x, y, and 0, 0. Make sure it's less than the radius of the circle. And what's the radius of this circle? If it's over here to -300, +300, well, its radius is 300. You see that? That's quite nice. So we can just say the distance between x, y, and 0, 0 is quite easy. You can say math.square root. We need math. Dist equals math.square root x squared plus y squared. And we can say was inside circle. And that's true if the distance was smaller than or equal to the radius of the circle, 300. Okay? So let's color our dots differently if like it's positive or negative. Okay? So if it's inside the circle or outside the circle. How do we want to do that? And say turtle dot begin fill, oops, end fill, and if it's inside the circle, maybe we'll change the fill color. If was inside circle, if that's true, turtle dot fill color is red, otherwise turtle dot fill color white. Hopefully that was correct. And that should, in theory, do it, unless I'm drawing the circles wrong. No, okay, so we have a few in the circle, a few outside the circle. Isn't that cool? So you can kind of see the circle being drawn, and with that, all that remains to do is calculate that ratio. So if it was inside the circle, we should also add like how many times it was. Okay, so count equals count plus 1, and we'll just start our count at 0. And then finally, at the very end, we'll be like print approximation of pi, and give let's see, we always threw 1,000 darts. So it's count divided by 1,000 times 4. Okay? So I think that should do it. And it's still drawn, so we're going to make it go super fast. Let me switch things around to make that happen. But it's kind of working, you can see that. That's fun. Okay, so I told the turtle to draw super fast, to skip some steps. Super fast, and then also I need this turtle to update to finish drawing. But now it should work, and it will then print out the approximation of pi down here. So let's run it. Moment of truth. Whee! There it goes, there it goes. Still drawn, still drawn, still throwing darts. And look, our approximation of pi here is 3.172. I actually tested this before and it got it perfect. So, or approximately perfect. So it is random, but it gets very close. And that's a fun little mathematical curiosity. All right, so that is that example. I'm just throwing a bunch of examples at you. Obviously, I'm not going to give you something that's difficult to do on the final, but it just is to practice all the things. The next bit of things that I want to talk about are related to just drawing multiple things. If you ever wanted to do that, let's draw a rectangular target logo. And we're going to do it in a special way so that it scales to make the real logo in a second. So again, functions come to the rescue. Let's make a draw square function that takes the center of the square and then also the width. Okay, so like here's the center and maybe the width is w. Okay, so it's w times w, of course. And so if we start in the middle, we're going to go to the center. And we'll say turtle.go to center. And then we need to like move up a little bit so that we can start drawing this square. We need to go width over 2 and then width over 2 up. So we can start drawing these corners, okay? So that'll bring us there. We go that way and then that way. And then we can start going right and then just keep on moving by 90 degrees each time. Yeah, and come back up. So that's how we'll draw our square. And we'll draw it with a certain color as well. Dun, dun, dun. Let's give it another parameter. Okay, and so we can use 3 squares actually to make this target logo. The outer one can be red. Boop. The inner one can be white. And then the one inside of that one can be red. And you just draw them in that order. And you have a rectangular target logo. All right, so new file. Import turtle. And this could be called target.py. And so we'll do it rectangularly. So def draw square. And we'll give it a center, a width, and a color. So for example, I can say draw square of, let's say, with a center of 50-50, a width 100, and the color can be blue. Let's try that. Okay, so this is how we'll do it. We'll say, well, let's get the width over 2, I guess. We need to go left and up by width over 2. So first, turtle.up, turtle dot, let's say, set heading. Let's make him go that way. Let's make him go west, so that's 180. And let's have him go width over 2 forward, and then let's turn him right by 90 degrees. We'll say also, again, go up width over 2, and that will bring the turtle to right here. Then we can plop him down, finally. Begin fill, end fill, then we'll also do the fill color of color, and now we just need to draw the square. We'll say, just go set the heading to east, which is 0, so face him that way, and we'll just start going width, 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 width. Not too bad, I hope. forward by width, and then we'll say turtle.right 90, and just keep on doing that. 4 times, go forward. Okay. In theory, that'll draw a square. We'll see if it worked. Okay, cool. It did. And so the center of this square was 50-50. We can make it like upright if we want to. Make it like at 200, 200. Draw a width 100 square. Yeah, that's the idea. Oh, sorry. It's not actually going to the center right now, is it? That's my problem. So turtle.up, turtle.go to the center. Yeah, that didn't look right. There we go. Much better. All right, so now we can draw a giant target logo if we wanted to. And how do we do that? Well, we can say draw a rectangular target logo. With a given center and a given width. Maybe we can do this. We can say draw a really big target logo in the center, colored red. Draw a square in the center with the original sized width, colored red, and then inside of that, draw a white one. So draw a square with the same center, with a width over, I don't know, width minus width over 3 or something, like 2/3 of the width, maybe? How about that? Color it white, and then make 1/3 of the width. I guess I can just say width times 2/3. This could be width times 1/3. And then color the last one red. So hopefully you see that this is all gonna draw a target logo, in theory. Let's have it be at 0, 0, and let's have it colored. Oh, sorry, there is no color, but the width can be 300. How about that? Okay, how's that? Invalid syntax because why? Oh, I need a def. Excuse me. There we go. So this function, none of these functions return things, they just do things. So there's no need to like save their result. We just call them, have them do their work. Moment of truth. Red, white. Cool. All right, there's our target logo. Rectangular this time. Actually, the color is a special color, and maybe I can find it, but it might be too late. I think I don't have any way of getting it. Can I see that color somehow? No, that's too bad. So that's a rectangular target logo. We can do the same thing to make a circular target logo. We can generalize this previous program. So here's what we can do, and it's going to get a little weird, but we can use functions that take functions as parameters. So instead of all this, draw a rectangular target logo, we can just say draw target logo. I'll comment this out. Using a certain kind of drawing function, okay? Using some kind of draw shape function. Draw a target logo with shape. So we can pass along the shape function. So we can pass along just as easily, and this is now draw shape instead of draw square. So I can pass along draw square, or I can pass along draw circle. Yeah? So watch me do a draw circle. That one's easier. We can say draw circle, center with color, go to the center, then we don't have to do any of this. Then we just say, draw the circle. By saying turtle.circle with the radius of the circle is width over 2. And that's it. So just as easily I can say draw target logo with shape. Draw square. 0, 0, 300. I can also do it with draw circle. So let's make sure that this one works. I'm going to do the same thing. And let's do it with draw circle now. So we can pass functions to functions. Whee! There it goes. Oh, no, I've done something wrong here. I think I used draw circle incorrectly. So, yes, it's going to make a circle with a radius given like where it starts. So we're going to have to change this around it a tiny, tiny bit. Let's see how turtles draw circles. So, counterclockwise direction. Interesting, interesting. So, yeah, we're just going to have to fix this a little bit, and then it'll be good to go. Okay, I fixed it. So because the turtle starts at the bottom whenever it draws a circle, it's like the turtle starts here, and then you give it the radius. You got to put it in a special spot. You got to like move down from the center after you go there. That's the problem. So get the center, pick it out into X and Y, move down by width over 2, and then you can draw the circle, and it makes sense, and it works. I've also gone and implemented a draw triangle function just to show you that it works the same. We can make the turtle go faster. And now we can draw triangles instead for fun. And there's some fancy math going on here, but that's beside the point. It's just that you can pass functions to functions and do cool things with them, and eventually end up with many different versions of a target logo. So I hope that was fun. That was the last real example that I had. And now I want to move on to some cool examples that I wanted to do in class, but just didn't have time to. So I'm going to give you the code and show you them running and briefly talk about them, and then that'll be that. Okay, so the first one is writing a turtle program that draws these kind of Pete Mondrian-like artworks. And there's a lot going on there, but the high-level idea is behind this program that I'm about to show you. Feel free to read it. Is you pick some random lines in each axis. You got some horizontal ones, some vertical ones, and that will be potentially the edges of a rectangle. So as you can see, the real rectangles, like this yellow one here, it is made up of starting from one end and going to the other end of a hidden rectangle. And alternatively, this blue rectangle here, it spans quite a few hidden lines, if that makes sense. So if you can pick some random ones, eventually it'll look right. And here is the algorithm that I wrote, and here's the code. Feel free to look at it. It's fun. Don't have enough time to talk about it, though, sadly. But it's good to look at and understand. And it just draws all those random lines and then starts putting rectangles between them. No, it's not responding because it wants me to keep on clicking enter or say something. And then it's going to draw a random rectangle with random colors. And eventually it'll look nice, and then you can be like, oh yes, this is the artwork that I want. Q for quit. And you have a beautiful piece of art at your disposal. So that's the idea behind that program. Very fun to think about and work on. The last one that I want to show you that I didn't have enough time for was, you know that Joy Division album cover shirt that all the hipsters wear? We can make that in code with turtles. So it turns out that this graph that is on this album cover is from like a signal coming out of a celestial body, and we can just copy that signal, and well, then we can display it in a graph form. So a lot of stuff going on here. I tried to add a lot of comments. Again, I wanted to do this in class, but we didn't have enough time. It's quite complicated, but it's fun to think about, and you can watch your turtle draw that diagram before your eyes, and you get to be the ultimate hipster, because at the very end of this, the shirt's going to be drawn perfectly. It's going to look amazing. And then also, you're going to have a turtle sitting there as well. So the addition of the turtle makes it even better, in my opinion. So let's wait for our turtle to get there. It's essentially just graphing all these points and then also drawing black rectangles around all the points as well, so that everything that you are graphing, like you want the frontmost graphs to like overlap the ones that are behind. So you want to like occlude them, make sure that you don't see them. Like this one, it would have, like, there were lines here, but it got rid of them. It made them black by drawing black rectangles. And so now we have this artwork with a turtle. Beautiful, huh? So that's really all I have for you. A bunch of little examples to just get your mind back in Python mode, get you ready for the final. Yeah, just remember that's going to be on the Tuesday of finals week, released on the Tuesday, due on the Wednesday at the latest. And that is officially the end of the class. So thanks for putting up with me. And I know several of you have already drunk the Kool-Aid, but if there are any of you who have not yet, I want you to consider being a CSCI major if you like what you saw in this class. Come take some more with me, or with another CSCI professor. So that is all I have for you, and I will see you at the final.